Slightly surprisingly, there are some occasions when B could take two different trajectories and still hope to intercept A. Let's look at a situation very much as before. You're in B, you spot A due north of you, 50 meters away, still going at 30 meters per second, but now it's going on a bearing of 130. It's coming sort of part of the way towards you, so you can afford to go at a slower speed, 24 meters per second, and still hope to intercept. Let's take a look. On a path something like that, let's just check. Yes, B intercepts A, covering ground where A covers ground at a faster speed, ratio 30 to 24. So at a time t, if time t is the time when they intercept, then A has gone 30t meters, B has gone 24t meters. Here's the bearing of t. That's now 50 degrees, so the sine rule again, sine theta over 30t will equal sine 50 over 24t. So sine theta is 30 sine 50 over 24. We could simplify, but really why bother? It's going to go in the calculator anyway. 30 sine 50 divided by 24.958. So theta is the inverse sine of that, 73.2 degrees. Excellent. But notice that there are more solutions to this equation. Theta, for example, could be 180 minus 73.2, or 106.8. And let's see what happens in that case. Let's go down a bit and estimate 106.8. Easily done. And now let's see what happens. Well, that was a pretty good estimate. Yes, they more or less meet. Clearly, in this case, A and B both cover considerably more ground before they meet. So which one you choose, I suppose, depends whether you want to meet A gradually coming alongside, or whether you want to be a bit more sort of head-on, a bit more confrontational about things. Your 73.2 or your 106.8. Now, in the previous example, we only used one value of theta, and I'll leave it to you to figure out what would happen if you tried to use 180 minus the bearing that we got in that case.